Okay, here we are. Thank you again.
This is a challenge for the planners and for the local authorities, for the county councils, to show them the impact and for them to visualise the coastal flooding.
But the highest recorded levels are over 8 meters above.
L'innalzamento della superficie del terreno e quindi con l'aumento dello spessore dei riporti.
For the construction of the harbor and all its some increase of the urban network.
The characteristic of Barcelona is the density of population.
Really great opportunity that is being used through the Urban Geo-Footprint tool is making this connection between urban geologists who are working in different countries, in different cities.
You can compare cities, different cities with the same parameters.
It has a lot of information that it's important concerning the city management.
Suppose that still awareness about the geohazards and general impact of the geological setting on the city.
Summary of the different issues that a city can be facing in terms of climatic effects.
Non è esclusivamente in quell'area, abbiamo attività sismica anche sulla costa, la fascia costiera, la maggior parte dell'attività sismica è concentrata in quella zona.
This place, a lot of people run, going away from the collapsing buildings, but they weren't expecting that the tsunami wave was going to come.
The Geological Surveys of Europe has a mission that is.
Okay, thank you. And now, according to our timeline, we have two opening messages. The first one is from Julie Hollis. She's Secretary General of Geological Surveys. Hello, Julie. I remind you that the UGF tool is developed in the context of a urban geology expert group. And the second message is from Luca Guerrieri. He is from HISPRA and is the national delegate of Italy for Euro Geosurveys. Thank you, Luca. Julie, when you want, please.
Thank you very much. So, hello everyone. Yes, as Valeria mentioned, I'm the Secretary General for Euro Geo-Surveys. The Urban Geology Expert Group is one of our 10 expert groups that connect experts from the geological surveys across Europe. And the Urban Geology Expert Group is particularly active and engaged in connecting both between the geological surveys, but also importantly in connecting with the public and with city planners and authorities. So from communities outside of our geoscience community. For me, it's a real inspiration to see how driven this expert group is in making these connections and sharing your knowledge with the wider community, as well as being open to the perspectives and knowledge of others as well in that context. The Urban Geo-climate Footprint tool is a really tangible product of that hard work and engagement, and I'm very pleased to, on behalf of EGS, to be here to help open the webinar. So I wish you a very good webinar. Thank you.
Thank you, Julie. Please, Luca, when you want, you can start.
Okay, good morning, everybody. The
Valeria said, my name is Luca Guerrieri, and I'm the national delegate for Italy. I also come from ISPRA, Geological Survey of Italy. Yes, this webinar is, of course, a fantastic opportunity for all of you to know something more about the Urban Geo-climate Footprint. But let me remind something about how we arrived to this day, because I have to say that when Francesco shared me this idea some time ago, I was also a bit, let's say, skeptical, because it was a really ambitious idea, but in the same time we encourage him to promote this, and the Eurogeo Surveys network was really the perfect network to consolidate this idea. In the meanwhile, there was a strong discussion in Eurogeo Surveys to establish this urban geology expert group that was a new expert group, and again, there was some surveys that were skeptical about the real need of this new group. Now, it's a fact that after, I don't remember how many years, this group is now a reality and appreciated, a very cross-cutting group that dialogues with all the other expert groups within Eurogeo Service. And UGF, the Urban Geo-climate Footprint, is a reality again, and the work that has been done in this time is clear, is evident, and the results that you will see this morning is a success of the work that has been, of course, coordinated by Francesco, but with strong support from many other colleagues within the Urban Geology Expert Group, so from all the other geological surveys across Europe. And also in particular in ISPRA, there is a supporting team that is very strong and very helpful, because nobody can do anything alone, but it's really a success of a dream team, I can say. Okay.
Thank you, Luca.
So have a nice webinar, and give the microphone again to Valeria.
Thank you. Thank you, Luca and Julie, again. And now let's move on to the core of this webinar, which is represented by 3 technical speeches, which allow us to respond to 3 questions. The first one is, what is UGF tool? The second one is, which are the results of UGF tool? And the third one is, how can we extend and share abroad these results? The first speaker is Francesco Lavigna, as already introduced by Luca Guerrieri. He is the coordinator of UGF activities. He's a PhD geologist and is also a member of Urban Geology Expert Group. Today, he will show us the main features of UGF tool and the recent updates of the 9.0 release. I remind the speakers to stick to the time, please. Francesco, you have 50 minutes and you can start when you want. Thank you.
Thank you, Valeria. And good morning to everybody. I'm really glad to have this first technical speech of this webinar. Probably for many of you, my presentation will be not completely new, but let's take into consideration also those who are exploring the urban geoclimate footprint approach for the first time. I am a frontman today, but there is a huge working group behind me, both in my institute, ISPRA, the Geological Survey of Italy, and in the Urban Geology Expert Group of Eurogeo Surveys, and in the different geological surveys which test the tool across Europe, and in other collaborating institutions as the University of Granada. So thanks so much to everyone who made possible to arrive to the results we are presenting today. I start my presentation, first of all, trying to explain in a few words what is the urban geoclimate footprint. The UGF this is the acronym of our activity, our project, is a new approach aiming to classify cities by geological and climate point of view. It works based on the decomposition of the geological and climate pressures existing in the city area in 5 drivers: the processes, superficial processes, geology structure, exogenous processes, subsoil anthropic pressure, that are defined by several parameters. The combination of those drivers produce the city classification, allowing city clustering by similar geological setting. The easy-to-read results allow the increase of awareness of non-experts on urban geology matter and the exchange of best practices to support policymakers. So why did we decide to work on this direction? In other words, why does it matter? You know, today, some 56% of the world population, that is 4.4 billion inhabitants, live in cities. And this trend is expecting to continue, with the urban population more than doubling its current size by 2050, at which point nearly 7 of 10 people will live in cities. The cities are subject to global changes and to the pressure of geological processes which interfere with the inhabitants' lives. To address global challenges, a collective approach to knowledge is essential, requiring coordinated efforts from countries and cities alike. So by characterizing our urban environments, geographically and geologically, we lay the foundation for resilient cities that can withstand future geological and climate shocks and stresses. So how does the UGF works? The UGF approach has been synthesized in a Microsoft Office spreadsheet, the UGF tool, organized in different sheets. This is a schematic representation of the UGF tool. In the flow chart, the different sheets are represented. And so the user navigates between the sheets and is guided by the glossary in the 22 parameters attribution. The final result is the city geofact sheet, a user-friendly document synthesizing the geological setting and the level of geological pressure of the city, ready to be shared with the public. Before going on, I need to recall some basic assumptions to take into consideration the UGF approach application. The first is that normally the footprints related to human activities are intended to be factor affecting the natural system and the resources. The urban geoclimate footprint must be seen reverse. That means that it will give a semi-quantitative measure of how much the geological complexity of the city area affects the city itself. The second one is that every parameter is to be considered with a negative meaning. Thus, the higher the parameter value, the higher the influence of the city is expected to come from its geological complexity. And last but not least, chosen parameters basic data must be available for all the cities of the same regional context if you want to compare them. Let's now have a look to how the tool works. First of all, you have to visit our website. The website is currently in a development phase, so you will see some functionalities we're still not working, but they will be active in the next future, I promise. In the home page, you find 3 main cards. That on the right side is still under construction. In the middle, you find the UGF map viewer, where the results of the cities analyzed until today are visible and questionable, and one of the other page will present some of these results. While on the left side, you find a descriptive section describing the UGF approach. By opening this card, you will be able to download the latest tool release 9.0 and relatively quick user guide. So you will be able to start your city analysis. When opening the tool, the user has to insert some parameters values and make some choices. In this slide, you can see a typical process to assign the correct parameters value. So first of all, you have to choose one of the parameters to define. Then you will open the glossary page where the parameter is explained, and so you can understand how to assign. You have to click on the link or the data set where you have to take the value, or you have to look at the map to have your consideration to assign the parameter. You have to insert the value in the cell. The parameter is calculated, so the score is calculated and weighted. And finally, you obtain a weighted parameter score. So when all the parameters have been inserted, the tool produces a preview of the results at the bottom of the table as follows. So you have every driver calculated as the sum of the parameter scores reported from 0 to 100 for each one. You have the UGF score index that represents the total geoclimatic complexity calculated for that city, together with other indexes. Last but not least, the UGF classification at the bottom and with the radar graph, consisting in the couple of the greatest driver presented. So here there are some new capabilities of the tool. Probably for those who are discovering the UGF approach today, this slide is not so important. Anyway, these changes remarkably improve the tool capability. So first of all, there is a new weighting define historical events of some shock parameters. What is it? The historical events are meant as very important events, even occurred and documented in the course of history, which have caused victims and or injuries or caused heavy damage to the city and its ordinary functionality. The user have to select if the historical event is yes or not, and obviously define the research, the reference, and the date of that event. We added some detail about the 4 EGS parameters in the results, so you can see not just the classification of the city, but also which one of the parameters have the highest values, and this helps to differentiate the cities as well. We added a new parameter considering the environmental ground and groundwater pollution inside the subsoil anthropic pressure driver. And we realized a new section related to geo-benefits. Why? It's very easy to understand. It's to highlight not just the negative aspects deriving from geology, but also the positive ones. Last but not least, again, the tool now is globally applicable. And so this is something also object of the next presentation of my colleagues. So this is the result of the UGF analysis, a way to make the invisible geological setting of the city more visible, the city geo fact sheet. This is a semi-automatic fact sheet which is defined by the tool, where the infographic are produced automatically based on the parameter insert in the other streets. In particular, we can see in it the city classification that is related to the intrinsic properties of the city sites. So just 4 of the 5 drivers I presented before. And the radar graph shape is proposed to be representative of the geological setting of the city. Then you can see the UGF index that is a dimensionless value representative of the geological pressure on the city. And then here you can see the geo-benefit section where 3 different positive elements characterizing the city are evaluated and combined. So the presence of groundwater resources, the general geothermal potential, and geoheritage value of the city. So what are the benefits expected from the UGF diffusion and application? So first of all, the general awareness of non-experts about the link between geological setting and increasing pressure due to climate change and anthropogenic activity. Cities with similar UGF classification will be able to exchange best practices each other to solve or mitigate typical common issues. And European and global institutions will be able to look at the city together to generally evaluate the differences between the expected impact of geology and subsoil-related climatic effects on the life of citizens, and be helping decision processes to define and differentiate policies and actions. Hopefully, the outcomes we expect from the UGF application could be an officially recognized classification based on the geology and climatic challenges and administrative tool, a better understanding of geo-environmental processes and their potential interaction with urban subsurface and infrastructures, thus also encouraging and supporting cities' subsurface resilience for sustainable future growth, and the support for the assessment of the economic and social well-being benefits that could derive from urban planning associated with proper subsoil knowledge. So how is this connected with cities' resilience? You know, urban resilience strategy identify many key aspects for cities to increase their capabilities of maintaining their functionalities, notwithstanding the challenges they are subject to. Behind visualizing exposure to hazardous geological and climatic processes, the UGF acts as a communication tool revealing another key aspect, the invisible city's primary infrastructure, the city ground itself, along with subsurface resources and geological functions and their associated benefits. So, in conclusion, borrowing our slogan, how to be aware, the UGF approach allows the general awareness of non-experts about the link between geological setting and the increasing pressure to the climate change and anthropogenic activity. How to be prepared? Cities with similar UGF classification, for example, will be able to exchange best practices each other and so be prepared to solve or mitigate typical common issues. And how to be safe? A more aware and prepared citizenry is also safer because it's more inclined to expect even the unexpected. So that's all from my side. I thank you so much for your attention.
Thank you, Francesco. You have been really punctual. So let's move on to the next presentation by Saverio Romeo. Saverio Romeo is a PhD geologist and also a member of Urban Geology expert group. Today he will show us the application of the tool to 41 European cities. And Saverio, when you want, you can start your presentation. Thank you.
Thank you, Valeria, for your presentation. Can you see my screen?
Yes.
Okay, perfect. So let me say that I'm very happy to be here and to share some information about this tool that I consider very innovative and with a lot of potential. And I'm very happy also to share to this technical community some preliminary findings. So let's start. I'm going to present some preliminary results about the first European cities we analyzed. So how many cities? Up to now, we analyzed 41 cities from 16 different countries. And as my colleague already said, the project has been developed within the Urban Geology expert group in the framework of Geological Surveys. This organization representing the Geological Survey of Europe involve 37 member organization with more than 500 experts. And so, first of all, we want to thank the many colleagues at this institution produced the fact sheet and analysis on their cities. We also would welcome contributors from other colleagues who would like to support us in disseminating this tool. Yes, up to now 41 cities and the potentially involved inhabitants turn out to be 34 million, corresponding to about 5% of the entire population of European continent, including the European Russia. So we have only 41 cities, but we can reach 34 million of inhabitants. Our cities range from London, with more than 7 million of inhabitants, to Tata, a small town in Hungary, with more or less 25,000 inhabitants. What is an urban area, or better, how can we consider a urbanized area? So we referred to the well-known degree of urbanization, also called the GURBA, provided by Eurostat, the Statistical Office of European Union, which classify the territory of a country of a rural and urban continuum. The degree of urbanization combines the population size and the population density, and start to establish three main classes: cities, towns and suburbs, and rural areas. So this local administrative unit are measured, are applied to a 1 square kilometer population grid cells. Here you can see a map specializing this classification around across Europe. Obviously, this is a dynamic classification that needs to be updated over time due to changes in land use, in population density, and so on. So coming back to our UGF index, I would like to go into detail, at least for the 5 main drivers, 5 colors of our footprint. The first one is geology pressure, which describes the geological setting of the city. So we consider physical aspect due to the geological structure, for instance, stratigraphy, groundwater, slope, and its complexity that affect a city. Then we have exogenous processes pressure, which describes all those processes due to meteorological extreme events and climate change, such as heavy rains, drought, and sea level change. Another driver is deep processes pressure, which describe the active deep geological processes. Aspect due to seismic hazard, volcanic hazard, gas emission, and sinkhole are considered here. The fourth driver is superficial processes pressure, which describe the geological processes and phenomena occurring on the city surface, such as ground instability, landslide, land subsidence, and the interaction with surface water bodies, rubber floods, for instance, and the sea, so coastal erosion. The last driver is subsoil anthropic pressure, which describes the effect on the city subsoil resulting from anthropic activities. So, for instance, soil consumption connected to degradation and pollution. So all these main 5 drivers give us a Urban Geo-climate Footprint Index, the UGF index. Here you can see a more detailed table with 5 drivers consisting of 21 parameters, and for each parameters you can see that we have a different type of calculation and weighting. Without going into too much detail, this slide just to present to you how the various parameters are calculated and weighted. We have 2 stages. The first one is parameter calculation, so we can choose different option, percentage, multiple answer, for instance, yes, yes, locally, not, or high, medium, low. Or another type is to use the values gathered from a specific map, for instance, the seismic global hazard map. Thanks to this first stage, we can reach a score, but this score has to be weighted based on 2 types of evaluation. The first is a spatial evaluation, so we consider our phenomena as widespread or punctual. The second evaluation is a temporal evaluation, so we have to consider our phenomena as a shock or as a stress. So after this second stage, we can reach finally a final score called W, the value of which ranges from 0 to 100. Yes, the UGF score index, that is the sum of the driver scores, namely the first and most simple parameter to rank our cities, varies considerably, spanning, as we can see from this table, from Sisak, the city of Sisak in Croatia, with 120 points, to Naples in Italy with 315 points. The mean value of the UGF score is about 190. Here we report a map with the cities analyzed, characterized by colored dots according to the predominant drivers. So for each city, we have chosen the predominant drivers that characterize the city itself. This category, we have 4 main classes. We can start with the first one, just to give you a brief introduction about the data interpretation. But let me say that in few months, we hope soon, all these consideration can be public in a scientific paper that is currently under review. The first class is Geo-exo, so geology and exogenous processes. This category predominantly includes cities situated within a river valley or alluvial plains. Notable examples are Milan, Bucharest, Budapest, Prague, and Zagreb. These cities are partially or entirely situated upon soft detrital sediment that house alluvial aquifer. The second class is the green one, exosub, so exogenous and superficial processes. This category encompasses cities of medium to large size, situated across a variety of fluvial landscape, for instance, Madrid or Lisbon in Portugal. The third category, the third class, is the yellow one, geology and superficial processes. These groups stand out highly diverse in terms of geological and geomorphological setting of the involved city, of course. The common denominator of these cities is the complex subsoil condition. Examples are Darmstadt and Cluj-Napoca in Romania. And then the last class, the red one, is GeoND, so geology and deep processes. And in this group, the city assessed with the deepest link to the geosphere stands out. Among the assessed city up to now, Naples is the only representative of this category right now. So we believe that increasing the number of cities, of course, this type of class, the red one, should be increased, especially in the southern part of our continent. So we believe that this clustering exercise is very important also to identify best practice and share them among cities characterized by the same geological complexity. This is very important in our opinion. Okay, here are some statistical results. It can be observed that the higher mean value pertains to the geo driver with a value of mean value of 50, other drivers being close to 40, except for the deep processes, so the red one, barely reaching the value of 15. On the right are the histograms of UGF scores composed by the various drivers where the great variability can be seen, of course. Regarding the 21 parameters underlying the 5 main drivers, a frequency distribution analysis was carried out, considering the present dataset. As 16 parameters provide a known outcome through fixed classes, for instance 0, 25, 50, 100, and so on, only on 5 remaining parameters was it possible to analyze the frequency distribution in more detail. Here, the rank of cities considering different drivers is shown. The position of each city along the ranking obviously changes when the different drivers are considered. Moreover, deep processes, for instance, the driver, again, the red one, seems to have a very different distribution within the sample cities, as about the 75% of the tested locality have a score below 20. This probably is due to the presence or absence of seismic area, or for instance, volcanoes, and so on. Yes, here we have tried to represent the data in a more attractive way, also to facilitate their dissemination to administrator, to policymaker, and also citizens. Here, a simplified view with, in the first row, the most representative driver for each city are reported. In the second row, the UGF index with a graphical counter and its value here below is represented. And in the third row, there is a radar graph that already was already shown by Francesco, my colleague Francesco, which represent the weight of each driver, the weight of each driver. So just to conclude, I have to say that we have several points, several considerations. The first one is the extent of applicability of the tool outside the Europe context. I think this is a very important point. We can say that this is a scalable tool, so we can apply this tool also in our part of the world, and we will have an example in a few minutes. We also welcome the interest of several geological surveys and countries from other part of the world, especially from Asia. There is still a level of subjectivity in the analysis linked to the experience of the operator. I don't know this is a positive or negative point, because and so we are trying to automatize the process, and again we have an important example in a few minutes. I think that in addition to the artificial intelligence, also the biological intelligence could be could play a key role in this type of exercise. The third point is that possible variability of the results based on the areal extension of the city considered. So to solve this issue, we have to set exactly the scale of the analysis. To do this, we already mentioned the GURBA classification, the degree of urbanization from Eurostat. And the last point is the importance of calibration and validation of the UGF tool. This project can be considered an open project, so we have a strong team that daily try to improve the tool, the structure, the architecture, so therefore always improvable. So let's say this is my presentation. Thank you for your attention.
Thank you so much, Saverio. Very clear and accurate presentation. This is your results are of particular interest for me because I, as you know, come from Naples. So thank you again. And before introducing the last presentation, we have just 3 minutes of break. There is a question from Francesco Lavigna? No.
Yes,
and,
yes. Sorry,
yes.
Valeria. Sorry for this not scheduled interview. I just want to highlight that the presentation of Saverio is something made with the previous version of our UGF tool. This is the reason why he spoke about 21 parameters and not 22 as I presented, because I was presenting the new one. And for the same reason, he spoke about 2 weights in the calculation, while I presented the third one that is new in the new 9.0 version. So I just want to specify this to make more clear the differences between the 2 presentations. So thank you.
Okay. Thank you, Francesco, for your clarification. I remind to all the attendees, the participants, that we can dig all the topics and all the issues also during the question and answer stage. So we have a 3 minutes break. See you later.
This is a challenge for the planners and for the local authorities, for the county councils, to show them the impact and for them to visualise the coastal flooding.
at the highest recorded levels are over 8 meters above.
L'innalzamento della superficie del terreno e quindi con l'aumento dello spessore dei riporti.
For the construction of the harbor and all its some increase of the urban network.
The characteristic of Barcelona is the density of population.
Really great opportunity that is being used through the Urban Geo Footprint tool is making this connection between urban geologists who are working in different countries, in different cities.
You can compare cities, different cities with the same parameters.
It has a lot of information that it's important concerning the city management.
Suppose that still awareness about the geohazards and general impact of the geological setting on the city.
Summary of the different issues that a city can be facing in terms of climatic effects.
Non è esclusivamente in quell'area, abbiamo attività sismica anche sulla costa, la fascia costiera, la maggior parte delle attività sismiche è concentrata in quella zona.
This place, a lot of people run, going away from the collapsing buildings, but they weren't expecting that the tsunami wave was going to come.
The Geological Surveys of Europe has the mission.
Okay, here we are again, and dulcis in fundo, there is the last but not least presentation by Azzurra Lentini. She is a PhD student from University of Granada. She is collaborating with us to develop the tool. And she's also working at the Joint Research Center. She will introduce us the extent of the results abroad, so globally and abroad. So Azzurra, when you want, you have 10 minutes for your presentation, please.
Good morning, everyone. Can you see my screen?
Yes.
Just launch the presentation. Okay, so my name is Azzurra Lentini, and I'm a scientific officer in the Geo Research Center of the European Commission. And also, as Valeria said, I started this project with my PhD at the University of Granada. So I'm very glad to be here with you today, and I want also to take the occasion, the opportunity to thank Francesco and the colleagues of ISPRA and the Eurogeo Survey for proposing this tool to the European Commission. Here at GRC, we see a lot of potentialities on this tool for collecting data, for understanding our cities, and finally for the contribution to increase the resilience of cities. So in my presentation, I'm going to introduce you the global capabilities of this tool. So the main key points in the new version that Francesco showed are related to the use of this tool, also to the use of this tool at the global, for the global city. So I will point out with my presentation, especially to this new characteristic that allow the tool to be used for experiment with the data of cities worldwide. So in this new version 9, there are many links that are related to global data sources. And therefore, we will experiment this city in different cities around the world. And this is the following phase of the experimentation after the one at the European level that was explained by Valerio. And so with this new version, we will also experiment the scalability of the tool. So we started from local level to European level and to global scales. So we will use data sources that have different scales and different resolutions. So to show you this version, I decided to select a case study. The first city that we where we experimented this tool is Port-au-Prince in Haiti. It's the capital of Haiti, and Haiti is an island that is in the Central America, near Cuba and Puerto Rico and Bahamas, in the Caribbean zone. And Port-au-Prince is the capital with 2.5 million of people. And in the same island of the Republic of Haiti, there is also the Dominican Republic. So when we experimented this city, so we introduced the 22 parameters that were described from Francesco, and we inserted the value of these parameters that are referring to the 5 drivers that are the geology, the deep, superficial, and exogenous processes, and the subsoil anthropic pressures. So I'm going to show you in this following slide the analysis that we did of this parameter, showing also some peculiarities of the city of Port-au-Prince and Haiti and the final results obtained. So as you probably know, the Hispaniola Island, that is the island of Haiti and Dominican Republic, is an important tectonic seismic zone of the Central America. The last 2 important earthquakes were on 2021 and 2010, and the one of 2010 was near the capital, near Port-au-Prince at the west, and caused more than 200,000 fatalities and more than 1 million of people displaced. So here we have some images of the capital of Port-au-Prince. Yes, the national palace of the government, and there are some houses and destroyed, and some shops. So this parameter that is part of the deep processes driver is the seismic parameter. So it's one of the deep processes parameters. And for example, in this case, what we took is the peak ground acceleration as a value for measure the UGF. And this value is in Port-au-Prince is around 0.5. And for this parameter, as global sources, we use the global earthquake model and the global seismic hazard map, the last version, 2023. And also local data when we had. And so we measure like the medium value of this parameter in Port-au-Prince. And here we have, here I show you another parameter, another driver, the geology. And so regarding this driver, Port-au-Prince has a high percentage of unconsolidated sediments that in the same cases show phenomenon of liquefaction, as displayed in this picture, in these 2 pictures. And this liquefaction was, for example, like triggered during the 2010 earthquake. And this is an image of the harbor of Port-au-Prince after the earthquake. So regarding the superficial processes driver, Port-au-Prince and in general Haiti is affected by floods, landslides, especially during the 2 rainy seasons and the 2 cyclone seasons. Here you can see some images of the debris flow in Port-au-Prince in one square of Port-au-Prince, and here the river erosion of the main river of Port-au-Prince, La Rivière Grise, and the floods during the rainy season and the cyclone season that flood and like the water go in all the houses and damage all the activities and houses of the capital. So, furthermore, like these effects of these factors of this hazard are amplified by the managed waste in the city. And here you can see an image of the clogged drain channels in Port-au-Prince. And also by the strong deforestation. So they manage waste in the capital, but also the strong deforestation in all Haiti cause an amplification of these hazards. And for example, here you can see the border between the Haiti and the Dominican Republic, and you can see the difference about like with the forestation of the two zone. So Haiti has a strong problem of deforestation, and this causes like the same cyclone, and this is the reason for why the same cyclone affect more Haiti than the near islands, also Cuba and the Dominican Republic. And with this also I introduced with this effect of the climate change has also introduced like the last another driver that is the exogenous driver. And also I show here in this slide also you can see like that another parameter of the exogenous process is the draw risk. And here you can see that Haiti and Port-au-Prince in general is affected by draw risk. On the left side, you can see a map from the Emergency Response Coordination Center of the Commission and the Joint Research Center, where it displays the standard precipitation index that is show that Haiti is as an index is extremely dry. And in this other figure, I show the one of the link and one of the data that we use for the UGF classification and calculation. That is a link of the World Resource Institution. And in this, you can see, following this data, you can see that the draw risk in Haiti is at the medium-high level. And another parameter that characterize.
Sorry, Azzurra, you have just 1 minute.
Yeah, I'm finished. Another parameter that characterize the last driver of my presentation, that is the subsoil anthropic pressure, is the consumed soil. As you can see in this, for this parameter, we used the Copernicus European Union, the land cover, and of the European Union Space Program. And as you can see, almost all Port-au-Prince is covered by built-up, and this is also reflected the high level of deforestation. And so we used all this value, all this link to fill the table that Francesco showed before, to arrive to the final result that showed that the index, UGF index, score index is very high at this point 386 as a value. And you can see here in this slide that the predominant factors that influence this final score are the superficial process and also the geology. But you can see also like the deep process and the exogenous process are very high. And the hazards that affect more Haiti are like the river floods, the earthquakes and landslides, and also there is a strong effect of the draw risk. And so with this final slide, I thank you for the attention. And I show again the bordering between Haiti and Dominican Republic. And I also invite you with this presentation, I would like also invite you for contact us for joining our research project and the journal publication, and to experiment together the tool in whole global cities. So I give back the floor to Valeria and Ispra, and thank you for the attention.
Thank you, Azzurra. Thank you so much. And now we are going to move to the final stages of our webinar, which is, we have approximately 15 minutes for any questions. And you can drop your comment in the chat, or if you are enabled to turn on your microphone, I don't know, you can ask what you want, ask for clarifications and comments. There are any questions from the audience? I remind you that you can also send us an email with any kind of clarification. Are there questions?
Valeria.
Yes.
In the meanwhile, we are waiting for any questions. I would like to ask everyone to visit the website of the Urban Geo-climate Footprint and to try to test the tool on the cities everywhere. This is very important for us. It's very important for this project, for the activity, and obviously we are really looking forward to receive some analysis, some other analysis from other parts of the world, but also from Europe as well. So this is just an invitation to communicate, to stay in touch, and to send us email comments and city analysis.
Okay, Francesco, if you want, you can also clarify the results of Saverio and the release, the further modifications of the release, if you want again to clarify better, because before we haven't so much time. So there is also
well, there is not so much to clarify more than what I said before, but I can repeat. If you remember my presentation, I presented 22 parameters. Well, I just cited 22 parameters because I presented the current version, that is the 9.0 version, that is downloadable from our website. Obviously, Saverio presented the results obtained until now, so the results are obviously made with the previous version of the tool. So in that version, the parameter was 21, and the weights were just 2 and not 3 as in the new one. I want just to add another thing. When you visit our website, you can download the Excel file that is ready to be used. The only thing is that when you finalize your analysis, you will see that the city geo fact sheet, so the final result of the analysis, is not the same you saw in our presentation. You find a filigrane on the city geo fact sheet. Why? Because we want to share the data after a very brief control about the pictures, if are correctly inserted, if there are no bias or typos. So we want to be sure that when the city is analyzed and the city geo fact sheet is ready to be shared and published, is completely double checked. So from the user and also by our side.
Okay.
So this is really important.
Thank you for the clarification. No question from the audience at the moment.
Valeria, so, just to answer you, just to emphasize, just to emphasize the invitation by Francesco, because the more cities we have, the more robust our tool will be. So I'll be sure it will be an interesting exercise to test the tool in your own city. Also because it's free, just contact us by email and you can do it. Thank you.
Okay, thank you. Okay, no comment and questions, just a message in the chat. So I think that we can conclude the webinar, and I'm going to conclude it with the final remarks and acknowledgement. Which are the lessons learned from today, and if you want the takeaway points of today's webinar. I've understood that sharing information and sharing best practices among cities with similar geological features, similar geological traits, can improve the awareness of the city, of the citizens, but also of local authorities, and improve and increase virtuous behavior in the urban context. And in this sense, I think that the UGF tool can give a significant contribution. I remind that UGF is developed in the context of a wide network of collaboration and partners. So I want to thank all the partners. I also want to thank the Italian UGF group for their contribution and their effort in developing the tool. Just one appointment. The documentary UGF tool will be shown on the website will be launched on the website on 4th of December 2024. And I thank you for the audience for their presentation, for their participation, sorry. And I hope that we may have conveyed you hints and interesting food for thoughts. Thank you, and see you the next time. I hope I've said everything. Thank you. Bye.
Thank you, everybody. Bye-bye.
Bye.
Thank you. Bye-bye.
Thank you.